Hi, my name is Eugene. I'm a developer at CoreOS, Flannel. And today I want to talk to you about Rocket, Flannel, and sort of the glue, the CNI, that Ilya sort of has alluded to. First off, how many of you are familiar with Rocket? Okay, just about. And what about Flannel? Okay. The reason I ask is I want to understand how much introduction I want to give to each one of those. But very quick, Rocket is our container runtime. It's able to run containers, either Docker containers or containers in the ACI format, which are the app container spec containers. And Flannel is our networking sort of SDN for containers. It's the fabric for networks. Sorry, it's the fabric for containers. And the way Flannel works is it uses etcd, which is our distributed key value store, as a storage and coordination medium. So it uses really etcd to distribute all the information that it needs to all the agents that are running on the host. And so today what I want to do is to try to do a demo showing how Rocket works with Flannel. So you just seen how Rocket works with Weave. So this is going to be very similar, but this time it's going to be running with Flannel. Okay. Don't fall. Wait, how is this supposed to? Oh, come on. Nope. Here we go. Don't fall. All right. Who knew this was going to be the hard part of the demo? Okay, so here is so I'm going to be running CoreOS 8.08. So this is sort of the earliest. This is the current alpha, and that's really the version that you need to make this work, because it ships the latest Rocket with all the bits that I needed for this demo. So, and the way we boot CoreOS is we use cloud config. So here's the cloud config that I'll be using. Okay, let's see, big enough? I think so. And let's go through it real quick. So the first thing is the Flannel. We are telling it to start, and then this exec start pre thing says that network, the thing in red that you probably can't see, but it says network 10.1.00/16. So that's telling Flannel to use this IP range, and that's what it's going to divvy up for all of the containers and give each container /24. The next thing is just QEMU networking to give static IPs to the containers. And then see the thing at the bottom where it says write files, and then let's see if you can make it bigger. All right, so this part. So the first thing is it says path, and it gives a path in etc rocket netz. That's where the file is going to get written out. Then there's like permissions and order, nothing interesting. But then there's the content stanza, and the content says it's a little JSON document in case that just has it's a dictionary with two fields. It's got name, container net. That's just a name that we're going to give to our Flannel network. And then type is Flannel, and that tells the Rocket that it's going to use the Flannel plugin, and it's going to hook up to Flannel that's going to be running on these hosts. And we're going to look into how this thing works on the inside a little bit later. But for now, I just want to kind of show you how it works. So we bring up Flannel on each of the nodes. We give the Flannel network a 10.1/16. Flannel is going to allocate a /24 to each one of the hosts, which in this case is I'm going to be running 2 hosts in KVM. And then we tell Rocket to, here's your configuration for the networking, which here's the name is ContainerNet, and the type is Flannel, meaning that hook up to Flannel and use it. OK, so let's see. Let's see if it's big enough. OK, so here goes the first VM. Hopefully it boots. CoreOS. Booting, booting, booting. All right. Let's see if we can SSH into it. Big enough? OK, SSH'd. Let's boot up the other machine. Booting, booting, booting. Other machine is up. OK. So here, if I do ifconfig, we'll see three interfaces. So the first one, ES3, that's just the normal host interface. But the second one, Flannel 0, that's the interface that Flannel has given to this machine. And see, the IP is 10.146.0. So that 10.1, remember, that's the Flannel network. So the 10.146/24 has been assigned to this host. And that's what's Flannel 0 is given. And if you do ifconfig here, we'll see that this host got 10.144/24. So now these two hosts should be able to ping each other via Flannel by using the 10.144 and 46 addresses. But we are not actually going to ping them from the host. We're going to ping them from Rocket container. So the first thing we're going to do is we're going to spin up a Rocket container. And here's the command line at the bottom, which says RocketRun -- private net, which tells it to allocate its own private networking stack. And the -- interactive so that we can get a shell. And then that SHA is just, I didn't want to rely on the Wi-Fi and pull down the image from the internet. So this is just stored in my CAS. It's an image with Alpine, small Alpine Linux distribution that on startup just goes into bin shell, bin sh. Okay, so bam, we're in the container, and if you do ifconfig, you'll see two interfaces. So the first one is the one that's really what we're interested in. It's the 10.144.7. So remember, this host was allocated at 10.144/24. So all the containers that are going to be spun up are on this host are going to be given IPs out of the /24. Yes.
So is that through DHCP? How does that fetch?
So Flannel is the one that was responsible for allocating for the container.
That's 44 now.
So the network was allocated via Flannel. So the Flannel uses etcd, the key value store, to coordinate and give everyone a unique IP. No DHCP here. And then once it gives a /24 to the host, then we'll see later how the .7 got allocated to this container, just a little bit later. But all the containers are going to get IPs out of the 10.144/24 range. OK, so we have this one container up and running, and then we should be able to do the same thing here on the other one. Same image. So this one is got a 10.146.6 because that one was it was allocated 10.146/24. Now, I want to briefly mention what that other interface is, that ETH1, which got the 172.16. That's sort of the default network that we add. It's only there so that the container can talk to the host, because we have something called the metadata service running on the host. And it's also the default route, so it can egress the network and go to the internet via that network. But the one that we're interested in right now is the container network, which is the ETH0. OK, so now if we take this IP, we copy paste it, and let's see if we can ping it. Yep, and we can ping it. So we have two containers running on two different hosts that are able to ping themselves by the IPs. This is using overlay network provided by Flannel underneath. It's using what we call UDP encapsulation, but we have multiple encapsulations, VXLAN and other ways to actually traverse the network, but that's sort of outside the scope of the talk. OK, so the demo seems to have worked. Let's go back to the slides. OK, so what what I want to talk to you about is this. So we have container runtime. In our case, it's Rocket. And we have to solve the networking problem. And there's really no one-size-fits-all in the world of networking. We have to make the thing pluggable. And so we want to have networking plugins. So these are the things at the bottom, some point-to-point, maybe via bridge, weave, as demonstrated by Ilya, Flannel. But if you're going to have all these plugins and we're going to have a container runtime, we need something in the middle. We need an interface. So that interface is what we call the Container Networking Interface, or CNI. So CNI is our proposal to kind of provide a common ground to the containers and the networking plugins over which they can communicate. OK, so the basic premise of CNI is that we have a container, and we have networks that are provided by CNI, and then the container can join multiple networks. So in this example, it actually joined two networks, as you saw. It joined the Flannel, which was the container net, and then it also joined the default one. The default one was automatically added by Rocket, so you don't see the definition for it, but you could imagine adding multiple networks, maybe one for your database tier, one for your web tier, and they can live on different networks. So the networks are described by JSON config, which you saw briefly, but I'll go into a little bit later. And then the plugins are super simple. They're executable files, and then they get launched with some environment variables and a JSON config that gets piped into them, and they just have to support two commands: add and delete. Add gets executed when the container is coming up and it needs to get added to the network. And when the container gets torn down by the runtime, it calls again into the plugin and tells it with the command delete to delete the network, to delete the container from the network. OK, so here's what these config files look like. In the case of Rocket, they live in etc rocket netd directory. And you give it a name and then the type. The type is really the type of the plugin, which ends up being the name of the executable that's going to get launched. And then, so the top level plugin here is bridge. So we're going to be using bridge networking. And then the IPAM is the IP address management section. That defines how the IPs are going to get allocated to these containers, right? And the IPAMs, they're plugins in themselves. They're like the little nested inner plugins. So the IPAM section here, type host local, that's for the IPAM plugin, and that says that on this host, here the subnet out of which you're going to allocate is 1010/16. So the first container is going to get like 1010.02 and then 1010.03 and 04 and so on. So this is just, and the state is persisted on the host. It's not distributed in any way. It's very simple. It's just a bunch of files in a directory to keep state. OK, so now let's take a look at how this thing works from the perspective of Rocket. So container runtime, such as Rocket, the first thing it does when it's bringing up the container is creates a new network namespace, and it gives it a named handle in a form of a bind mount. So once it has a handle to the network namespace, it calls into the plugin. So it opens up that JSON configuration, and it sees that the type is bridge, and then it finds in a predefined path, it finds the executable called bridge, and it just executes that file, and it gives it a few environment variables, and it pipes in the configuration file through standard in. So then inside of the bridge plugin, what happens is that we create a new bridge. We create a WETH pair. We put one end of the WETH pair, plug it into the bridge on the host. We take the other end of the WETH pair and we put it inside the networking namespace that was given to us by Rocket, or the container. And at this point, we got kind of the layer 2 networking up and running. So now we have to figure out the IPs. So the next thing that's going to happen is that the bridge plugin is actually going to peek into that IPAM section. It's going to see that the IPAM type is host local. It's going to again find that executable by that name. It's going to exec it, again forward the config file to it. And then the host local is going to allocate an IP and through standard out, print out a little JSON snippet you see here saying container, here's your IP. Your IP is 10.10.5.9 and here's your gateway. So this now goes back to Bridge plugin. The Bridge plugin can see, oh, here's the gateway that I should be using since it's the very first invocation and the Bridge doesn't have an IP yet. It's going to assign 10.10.0.1 IP to the Bridge. And then it's just going to it's going to add the IP for the container to the interface inside the network namespace, and it's going to return. So that's, and then something very similar is going to happen on the way down when we're deleting the container. So we actually have a couple of plugins implemented right now in inside the CNI code base, and you see here. So the top level is that the top level, the thing that Rocket is going to invoke, and then the IPAM is what the top level plugins are going to invoke for the IP allocation. And you can sort of mix and match. Obviously, not every combination is going to make sense, but for example, Bridge works well with host local, DHCP. Mac VLAN works very well with DHCP. This way you can get you can give your containers actual IPs from your network if you have enough IP space on your physical network, and you don't need overlays or anything like that. Then you don't need it. So now, how does Flannel fit into this? Yes.
So your very first slide had networking technologies, Weave, Flannel,
Right.
and so forth. And how do they map to your top level plugin?
So
I don't see Weave on that list. It's sort of my puzzle.
yeah, so Weave and Flannel are also top level.
What was the question?
So the question was that a couple of slides back, when I referenced the plugins, there was Weave and Flannel, and they're not in this list. How do they relate to this list? So Weave and Flannel are also plugins that should be in this list. And Flannel is in this list, and I'm going to go over this next. And Weave, Ilya has alluded that they're working on this plugin as well. So another plugin is that we have, another CNI plugin that we have is Flannel, for Flannel. So here's an overview of how Flannel works, but we've seen that. But the thing is that, well, okay. So the user puts in a config into etcd, then those three circles are the hosts. So subnets get allocated to those hosts. And then once Flannel is up on any given host, it spews out this little environment file, like key value file, onto disk, saying here's the subnet that I've allocated for myself, along with some other information. But the important one is that second line, Flannel subnet. Okay, so how does it then work? So Flannel, like the meta plugin, but so here's how it works. So this is the thing on the left, the name mynet type Flannel. Remember, that's the thing that you saw inside the cloud config at the very start of the presentation. So what CNI Flannel plugin is going to do is it's going to take that configuration. It's going to suck in that file that was outputted by Flannel once it was up and running, that lives in run Flannel subnet env. And it's going to write out, it's going to generate another JSON for the Bridge plugin. And then it's just going to call into the Bridge plugin. So we're chaining plugins. So what's going to happen is that the very top level plugin in this case is Flannel. Flannel gets launched. It takes some information that Flannel spewed out. It generates yet another JSON, and then it calls into the Bridge. The Bridge is going to use the information in this config file. It's going to do its thing, like we've seen from the previous slides, and then it's going to call into the host local to allocate the subnet, to allocate the IP for this container. Now, the host local plugin, if you recall, it's not distributed. It just looks at 10.116/24, and it's only on this host, so the state is not distributed. But because this file has been generated by the Flannel plugin from the information that Flannel has spewed out, those subnets are not going to be intersecting. So every host is going to have its own /24, and that's how it's going to get propagated all the way into the container, and that's how the container gets a very unique IP on this network. And finally, here's the thing, you can do a RocketRun, we've seen that. And if you have more information on this, the following URIs, CNI, Rocket, Flannel. We also today, I don't have a link for it, but we published a blog post on how this kind of step-by-step on how to go through the steps that I've just demoed. So if you head over to CoreOS.com/blog, you'll see it over there. And I have about 5 minutes for questions. Yes?
Does all this work with IPv6?
No.
Thank you.
Sorry, the question was, does it work with IPv6?
So a follow-up, when will it work?
Soon. Actually, we don't. So when will it work with IPv6? So IPv6 is definitely in our mind, and the CNI spec, if you look at it, actually does talk about IPv6, and it has all the fields for IPv6. It just hasn't been implemented. And the primary reason for not implementing IPv6 at this point is I think it's kind of straightforward. I think it's important to figure out that if the concepts all work together in IPv4 first, and then hopefully it'll be a fairly trivial matter to convert it to IPv6. We'll see. Yes?
So when we make these scripts, we're hard coding in a pile of IP addresses in lots of interesting places. Is there any point at which we can abstract this a little bit more so we don't have hard-coded IP addresses in all our scripts, and then when we change it, we have to re-edit all our files?
Well, so if you, in this solution, if you actually look at when I demoed Flannel as the CNI plugin, in that configuration there were no IPs. There was just the name.
It's not the .env file that has a hard-coded IP address.
But that's auto-generated by the Flannel. That's the job of Flannel to not make you hard-code the.
Yeah, but if you looked at your original Flannel description, I mean, you hard-code an IP range.
Yes. So you have to somewhere tell Flannel that here's the IP range that you're going to be using. That's in the world of Flannel, that is the only IP range that you have to specify, because we can't really assume, we have to pick some IPs, but we can't really assume that, if you pick 10.116/16 that it's going to be available, because we don't want it to conflict on your network.
But if you look for a moment at how people run when there's no container environments and virtualized environments and basically any data center, we don't hard code IP addresses into configuration files even for the Flannel world, and a lot of these things seem to be forcing us to. Actually,
you do in a lot of work. A lot of times you use DHCP, right?
Yeah.
But so the question was, in the real world, in real data centers, people don't end up hard coding IPs. I would actually argue that you do, because when you set up a DHCP server, you actually give it an IP range out of which you're allocating. So in this case, Flannel is very much acting like a DHCP. The only DHCP hands out IPs. Flannel is handing out IP ranges.
But the point is, DHCP is generally administered by a network administrator, whereas Flannel is by every dev and op.
Well, I'm hoping. Flannel is a piece of a networking infrastructure, so as such, it should be administered by the networking administrator. I guess that's the, and I think that's kind of, if you have a SDN, I think the SDN should, one way or the other, be either administered by a network engineer or at least be done so with his or her collaboration. That's going to be.
Can you go over 256 containers per host?
Sure.
So just multiple subnets?
Who would ever need more? Well, it's configurable, right? So by default, it's /24 basically. But you can, it's when you say there's subnet len, so you saw network, and then the next thing you can say subnet len, and you can give it whatever you want.
Can they container ping each other with the name or ID?
With the what name?
With the name or ID instead of IP.
So the question was, can the containers ping each other by name? The answer is no. So the answer is Flannel is not responsible for that. So this is the job of DNS or service discovery, which is anytime you talk about a name, I think, And that's something that's sort of orthogonal to this. If you're running Flannel, you're running etcd. And if you're running etcd, I highly recommend you look at SkyDNS, which is DNS backed by etcd. And then you can register your containers into basically SkyDNS, and I'll pick it up from there. But it's sort of a separate concern. But I agree that in production, you probably want to build up a layer on top of it. Yeah.
So CNI is CoreOS's proposal for this interface. Could you maybe talk a little bit about that and who's behind it? Question one. And the second question is, if you're just using Mac VLAN, for example, why do you need CNI? So I can see where it's getting useful for Flannel configurations. But if I'm just using Mac VLAN, for example, what's the value of CNI?
Okay. So the first question was, who is behind CNI? So the CNI proposal is from CoreOS, but we've had parties from Google and Red Hat. Weaveworks look at it, give us Cisco, they gave us feedback. They're considering its adoption or using it in some way. So it is a proposal that we've put out, but I think it's being, we're hoping that it'll become a community project, yeah. It is basically under the FC umbrella, yeah. So the second question was, if you just want Mac VLAN, why do you need CNI? If everyone in the world wanted Mac VLAN, we won't need CNI because all the container runtimes could just always use Mac VLAN. The problem is that some people don't want Mac VLAN, and so that's we need them to make that strategy pluggable. Some people might want Mac VLAN, some people might want IP VLAN, or whatnot. So we need to make the pluggable, and if you're going to define plugins, you need to define an interface between whatever is invoking the plugin and the interface that the plugin is going to implement. So that's where CNI fits in. Yes.
Do you support like IP multicasting?
Do we support, and by we, do you mean Flannel or CNI? Flannel does not support IP multicast. Yes, Darren.
So in CNI, what's the definition of a network?
A network is a group of containers that want to talk to each other, basically. It's kind of vague, meaning that if you try to define a network in a traditional sense, you would say that it's a group of maybe like a subnet where the broadcast domain, or maybe something in a sitting on the same router or something, or a set of group routers. We are a little bit more abstract. We loosely define it as basically that if multiple containers join the same network, then they'll be able to talk to each other.
Via layer 3.
Via something. That's why the thing is that we don't really impose via what.
But the interface at the container level will be IP, right?
Yes. The interface is going to be IP, but the thing is that, so yeah, I guess you can say it's at layer 3 at IP, but we don't really say that it's going to be via 100% via routing, or there's going to be some kind of a broadcast domain between them.
That's the piping, right?
That's the piping, yeah, we're agnostic from that. Yes.
Does CNI, does it provide any introspective capabilities? I mean, to list containers or network, any of the networking information on that?
So when the CNI plugin executes, when it does an add command, what it spews out to the caller, which is the RocketRun runtime or whatever other runtime, it spews out a little JSON document that says, here's the IP that was allocated and some other stuff. It is the responsibility of the container runtime to store that information somehow and then provide the UX for displaying it. So in case of Rocket, you can then say Rocket list, and you'll see your containers, and for those containers, you'll see the networks that are joined, and you'll see the IPs that they're using. But that's the responsibility of Rocket. That's not the responsibility of the CNI. CNI plugins expect to just output the information to the container runtime. Sorry, and the question was, is there any introspection capabilities in CNI? Probably have time for one more. Yes.
So is there any security model for CNI in terms of?
No, there is no security model as of yet. It might be added. In fact, it's kind of, if you have a container and a joint, so say you have 2 containers and one container joined one network, another, well, now we need 3 containers probably. On one host, this container joined maybe these 2 networks, and another host container joined another 2 networks, but one of them is common, like A and B and B and C. Then what we guarantee basically is saying that every container is going to be able to talk to, if you joined A and B, you'll be able to talk to other containers that joined A and B. But you might also be able to talk to C. It means the CNI does not prevent it per se. However, something else, and looking with Kubernetes, needs to provide the policies around at what level do you want to segment your networks? Do you want to services? Do you want to segment at the network level, or do you want to do some kind of micro-segmentation where you're segmenting at service level and where you're doing those IP tables rules, for example? So right now, we might add something. We might add security and firewalling basically at the CNI level. We haven't yet, because I'm not sure if it's, feedback welcome, but because I'm not sure if the segmentation should actually be done at the networking level, at the network level, or at something much finer grained. And there is a probably even longer answer to this. I just don't have time to go into it, but it is something that's especially being discussed on the Kubernetes. So if you join the Kubernetes networking SIG, then it's definitely discussed there. All right, all the time I have questions, but find me afterwards if you have any more. Thank you.